Hello everyone, myself Tanmay Barge. Today I am going to teach how to modeling of 2 degree of freedom damped and force system using Simulink and Simscape. So let us understand a basic theory related to it. So when a system requires more than one coordinate to describe its motion, it is called a multi-degree of freedom system or n degree of freedom system, wherein is the number of coordinates required. Thus a 2D of system requires two independent coordinates to describe its motion, and it is simple of and degree of freedom system. For a 2 degree of freedom system, there are two equations of motion, each one describing the motion of one of the degrees of freedom. In general, two equations are in form of coupled differential equations. So in this case, where I'm assuming a harmonic solution for each coordinate, the equation of motion can be used to determine two natural frequencies or modes for the system. So here is a basic problem statement we are using to model using Simulink and Simscape. So this figure consists of two masses M1, M2, two spring K1, K2, and two dampers C1, C2 respectively, which are having motion in two coordinates, and the force F is acting on the mass M2 at the right hand. Hence, we can say it is a 2 degree of freedom system. From the above system, we can get the equation of motion as follows: M1 x double dot equal to K2 bracket x2 minus x1 plus C2 x2 dot minus x1 dot minus k1 x1 minus c1 x1 dot m2, and the second equation is m2 x double dot equal to f minus k2 bracket x2 minus x1 minus c2 x2 dot minus x1 dot. So using this equation, we are going to model our Simulink and SimScale model using MATLAB software. So let us open our MATLAB software. So using this MATLAB software, we are going to model our problem. So here are the basic values we are going to use for our model. So first K1 is 70, K2 is 50, M1 is 10, M2 is 20, C1, which is the critical damping coefficient, is 2 into SQRT, K1 into M1, zeta 1 is 0.54, D1 is CC1 into zeta 1, and D2 is 25, and force we are using is 50 Newton. So let us run our program. So after running, we have to open Simulink software. So first we will open Simulink software. So this is our Simulink software, and we already model this using Simulink. So I will explain each block one by one. So this bigger one block, as we can see, is this bigger one block we are seeing is the sum block. So here we can assign different values such as K2, D2, K1, D1. This 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 triangular block is called a gain block. This is called the integrated block. So we are using two integrators. We have two values to assign, which is x1 and x1 dot. And same block where, so this each block represent each equation. Design will be like this, and for our second equation, our block design will be like this. In, as we know, in the second block we have a force. We are using a force of 50 kilonewton. So we have assigned this value to the second block. So after this, we are going to run our software. So after running our Simulink software, we can see our result in this scope block. So as we can see, as we have used the 2 degree of freedom system, we are getting two graphs for each mass and spring system. So for first mass and spring system, we are getting a bigger overshoot and undershoot amplitude, and after some time, due to the use of damper, we can get a straight line. Similarly for the second block, after certain overshoot and undershoot, we get a straight line as we have used damper for both the cases. So this is how we can get the results using our Simulink software. So let us see the results using our SimScale software. So I just open SimScale software. So this is the basic modeling of our SimScale software. So as we can see, here is a fixed reference point. Here is a solver configuration, motion sensor. As we are going to use two masses, there are two masses, two springs and two dampers. So using this, we are going to run our software. So let us see our results in the scope window. So as we can see, we will get the same results. But it is more enlarged as due to the software variation. So we are getting the same result using the SimScale also. So here are the two ways we can model our problem. So let us see another example for our problem, for our model. So in this case, we are assigning different values to our model. So first one, K1 is 55, K2 is 70, M1 is 30, M2 is 20, C11 is 2 into SQRT, K1 into M1, Zeta1 is 0.54. And similarly, all these values we are assigning, and force we are assigning is 60. So we will again run our software. And we'll again open Simulink. So here also we will run this. And we will get our results in this scope block. As we can see, here is a little variation in this as the damping coefficient was higher in the second case. So we're getting a straight line after after only after 10 seconds we are getting a straight line. So as we can see, if the damping coefficient is better, we can get easily damp our problem. So this is how we can use Simulink and SimScale for modeling our software. So here I end my video. Thank you.